Fantastic. Good afternoon, everyone. My name is Hardy, and I'm a solution architect at AWS. I'm based out of Denmark. I live in Helsingør. Just want to do a quick survey. How many of you have heard of KRO? Wow, fuck man. Okay. How many of you are here because you saw Victor Farage drop a video that said, "Is cross-pane or is KRO the new cross-pane?" Oh, all right. So that's good. All are welcome. So today I'll be talking about KRO, and I want to bust the myth right away before we get into, is KRO the new cross-pane killer? Not really. That's not at all how we think internally within Amazon AWS, and that's not how I see as part of somebody who works with the KRO team trying to do something new that I think there is a need that could fit in the Kubernetes project, right? So I hope I've set that as a base. I'm not here to say there's a new competitor. So I'm really here to talk about Kubernetes, and particularly in the sense of platform building, right? So as a solution architect, I work with customers at scale that are trying to build platforms that have the need to build abstractions over their product offerings, right? They are large enough where they have to manage a sizable set of applications, mega thousands of developers, applications that needs to be abstracted away so they can deploy things without really thinking a lot about how it deploys, how it gets deployed, and those things. So Kubernetes fits this platform really well. I'm really happy that the Kubernetes project thought about it. They did not try to solve everything. They just went about saying, Kubernetes, we let it be really extensible. You can extend it to whatever you want. We will not solve all of your problems. There's great abstractions packed in. Use those abstractions. Use the power of extensibility. Go figure out. We will not solve everything and every little detail that your organization might need. And that's great. And that's one of the reasons why I think Kubernetes has excelled really well in the modern platform building. So Kubernetes is great, but it comes with a set of challenges, right? If you are a developer, getting into that L100, etc., is easy, but as you scale to 300 plus, the scale gets to be a problem, right? There is a steep learning curve there. Understanding how your resources work in relation with your application soon turns out to be a challenge. And the biggest thing that I find my customers struggle is the sheer amount of YAML you have to write. I call it the YAML complexity internally. That is quite a little bit of issue for some of the platform builders. For platform builders, they are put into a position where they need to simplify everything, standardize everything, but have minimal constraints. Don't put a lot of constraints on me as a developer. I want to have as minimal constraint, but I really want it to be standardized. I want it to be certified in all sort of security things, and I need it to be very simple, which means I have to put things on rails, basically. I need to establish the organization standard on the platform, because for a lot of organization, when you have a platform, a developer platform, that is the operational model where you bring in change, where you bring in your products and do ship products through those platforms. So that means you need to maintain those organization standards. Taming those resources is paramount, and it can get complex, right? Well, this is where custom controllers comes in, right? They're like, wow, okay, Kubernetes allows you to be extensible. That means you can start off with just the pods and deployment, but then you can extend it to pizzas. Custom controllers comes in here because the custom resource definition is a way where you can extend the defaults of Kubernetes to something that you want it to be. Well, this requires specialized knowledge. It needs you to invest time in it and mature it, nurture it. It takes time. there could be multiple moving parts. You need to be aware of that. Often, the challenge I find with my customers that I work with is that they would have built a set of operators, baseline operators, and then have another operator to manage those baseline operators. And then maybe another layer to manage the first year CRDs or operators, right? So you have this pattern of multiple operators that are basically managing configurations of other operators. That's basically what some of the platform engineers are spending time. That's basically time spent away from your products. You should be spending time on your products, building features, building your business. Not operators that just manage another operator's configurations or CRDs or config map, whatever it might be, right? So Kubernetes is endlessly customizable. What do I mean by that? Let me just walk you through a sequence of code, and let's see, is this something that you relate with, right? I've oversimplified it so that we can level up and understand here at the same level. What I have is I just have a simple Minikube cluster running, nothing installed, everything is local on my Mac. And let me just do a quick kubectl API resources. Kubernetes is something that you can operate over REST. You can do create, update, delete, and you can just pass objects, you can patch objects. And kubectl is just a CLI that wraps those REST calls for you. Handy, right? So I'm just going to run some kubectl. Try it out, right? Let me just switch this to sidebar. So, and maybe it just even goes Zen. Right? Let me just start to run this. What happens if I run Kube API resources? I get to see all the different resources Kubernetes manages. This is what comes out as default. And you can see familiar terms. There are pods, there are deployments, there are secrets, there are services, there's events, roles, cluster binding, etc. These are the defaults when you start off. And every resource there is something that you can actually create additional stuff. You can create roles, or you can create secrets, etc. via a REST API. So everything is just endpoints at the end of the day, right? That's great. So let me just do that, right? Let me use the API to do simple things like give me one more of some pod. Let me just run something where I'm just going to scale up so I can create more of those resources. I can just scale down to create less of those resources as well, right? So the things that comes as default, I can play with it. I can add more of it. I can remove. I can make things with it to serve my business needs. But what if the defaults are not enough, right? And my business comes in and say, hey, now we are in the sauna business. We don't do pods and deployments anymore. We are in the business of renting and creating saunas across Finland, right? And that's when I need to start writing those custom resource definitions, right? So here is an example of basically a custom resource definition where I'm defining the properties of a sauna, right? Like where you can toggle the temperature, you can decide how many bird trees do you want to have in case you want a really good beating. You can decide, some refreshments after your sauna session. You can do all of that. But if you're an admin on this extensible API, you want to make sure that there are certain things that only the admin has, such as disable bookings on the sauna. It's something only an admin can do. Maybe that kill switch in the sauna. Maybe that's only the admin toggle that somebody can actually perform. So you want to be able to do these kind of things if you're an admin, and if you're not an admin, just somebody who's booking sauna, just want to access only a part of the sauna API system. So here's the CRD, right, that I've just created, and I can just basically do a kubectl apply, and then get that CRD to be deployed. When I do that, what I see is that when I do API resources again, and then grab Sona, I see I have a new object of type Sona in my Kubernetes. That means I have a new endpoint on Kubernetes when I can say, give me more of those Sonas, right? I've extended the stretch of Kubernetes from just deploy to be able to say, give me more pods, give me more deployments, to say, handle Sonas. Great. One step ahead, right? So once I have the endpoint, I can start asking Kubernetes, can you give me a Sona, a lakeside Sona, with a temperature 95-degree max? I don't know if that's good or bad, but as long as you don't burn out. That's pretty high, right? I mean, I'm all the way from India, so I have no idea what Sona is. So you can see how clueless I am. So yes, post-refreshment, I've just gone with some nice Finnish beverages. And some, in terms of admin overrides, I basically said on this particular Sona, I shouldn't be able to disable any bookings. If I take a booking, I need to be able to honor that. And I've changed some of the admin toggles, right? So let's just create that instance of Sona. So if I do that, it just creates a lakeside Sona for me. That's great. So let me just try to create another Sona. This one is basically a cabin Sona, right? With a different set of here the temperature is 80 degrees, a bit cooler, right? So I'm able to create more of the same. You get the hint here, right? I've extended Kubernetes. It can handle Sona. It can create Sona instances in different places in Finland. Great. So what I've done so far is build a really expensive key value store, right? It's Kubernetes, but all it's doing is just managing some YAML files as a key value store. This is where you need a controller, right? Introducing another pattern here. A controller is something that watches and reacts to the changes in that Sona specification. So if the temperature changes on the Sona, it can say, hey, something changed there. And then you have another concept called operator, and the operator is basically where you can add your business logic in, right? So that's basically where you're adding domain intelligence, like if people are staying for a bit more than what they normally do, make sure the temperature doesn't drop down. So those kind of things, right? So operator has business logic, controller has the eventing that you can hook onto. So great. So the combination is what you need. And trust me, every CNCF project that you see out there, in some shape or form, are extending the edges of Kubernetes to new frontier, and that is via CRD. At scale, I see customers doing this within their organization to meet those platform needs for their application. They're not building Sona, they're building something more realistic within the organization. Right? This is the pain point. Because business is constantly growing and they're constantly ambitious. Nobody settles with the Sona and then says, I'm good. I want it to be integrated with Airbnb now, right? I want a bed and breakfast, and if possible, a restaurant where I can have some dinner after my Sona sessions. So you can see that the nearest extent is over time increasing. That basically means I'm sitting and writing more operators in my platform to be able to handle Airbnb bookings, bed and breakfasts, and restaurants, right? Okay. So what happens is I'm able to create the base operators that can individually manage Airbnb, a bed and breakfast, and a restaurant. But often I have the need to tie them up because the business want a chain, a spa operation. They don't want a Sona. They're asking, I need a spa operation. That means I need to combine all these basic building blocks together to be able to get a functional spa or spa, whatever is the right way to pronounce it. So that was a long introduction to to get to CRO, but I'll get there, guys. So the answer is, how do you actually stitch a whole range of Kubernetes operators, controllers, with something that is really abstract, something that is really agnostic to what are the resources you're working underneath. Okay, this is the point I want to promise. I promised Yuri that I would also mention. Listen, we are not the only one who solved this. There are other people who have solved this. Abstraction layer, Crossplane is one of those. Go have a look, try it out. But I'm going to continue with my talk now. I'm done with that, Yuri. I hope you're satisfied. CRO is basically a new kid in the town. It's a tool that is really young and in its infancy, still in the diapers. We're building along, but I think we have the right direction ahead. So what CRO offers is a Kubernetes native structured framework for resource group management and orchestration of resource group, or CRDs within your cluster. It abstracts away and automates native Kubernetes resources and extensions and any customization. And it helps you to build those standard models where you don't want to bring all of the complexity to your end developers. Abstract away only the things that they need. Was developed by AWS as an initial start, and then was soon followed by Azure and Google. It's not something that happens often, but here we are, right? So what platform building with CRO is basically, it's a tool that actually helps you to build the base building blocks and then switch them together, unify both Kubernetes native and cloud resources together, and offers a simpler way to write CRD. I mean, this is assumptions. We're still open for feedback. Is this really the simpler way, or is it more complicated? Sure, we're open to that. But our take is that writing CRDs is difficult. Can we simplify it? So how does it look in terms of platform building with CRO? So there are two parties here. The first one is the developers, and then the platform engineers. Platform engineers actually create yet another CRD called resource group definition. That's the standard model. They create the resource group definition, and underneath the resource group definition, you can pack as many resources you want. And these resources don't need to be conformant to CRO or anything. It can be any resources, any. Ingress, deployments, pods, cross-pane CRDs, Gartner CRDs, doesn't matter. You can line them up. All we want to know is, what are your APIs, what kind, and do you have an operator if we create a CRD for that, right? We have a single abstraction layer that can work with any CRD that comes with it, right?
So it's a true abstraction across different cloud providers, so that you don't treat it like the developer.
We did not think across different cloud providers. We just thought of it as
Simplified abstraction. Yeah.
across anything that's a CRD, right? So we don't want it to be conformant to a CRO standard CRD or anything. As far as we are happy, there's a kind and a API extension, and there's an operator behind it. It's good to go. So what does CRO do as a core concept? So it dynamically creates the end CRD. It creates the CRD under which you are, for all the resources that you've added under the resource group definition. And it registers the CRD for you, right? It's doing the heavy lift of, well, I've got your spec. Based on a spec, I'll create the end resulting CRD and register that for you, right? And there's a single controller for all your CRDs. That's not like every CRD is not followed by yet another controller. It's single CRD, and all the mechanism is within that single controller to help your ever-growing list of custom resources. It actually detects CRD breaking changes ahead, so you can actually be sure that you don't have any big bang surprises in a cluster, and I'll just show you in my demo what that means. We're building on top of OpenAI compatibility. Of course, we don't want you to write a whole lot of YAML, but if we can, for a good reason, if we can combine that YAML with a whole lot of cell expressions, thank you, Google, if we can actually do that, that'll be perfect, right? So I don't have a YAML for my default configuration, a YAML for my production configuration. I have a YAML for my staging configuration. What I can do there is that I can use the cell expressions to abstract away the environment things. I can have a single YAML. Depending on the parameters, I can actually create variants of those YAML, basically. Really, really nice. But again, this is something that would split hairs. You have people who really like YAML just to be YAML and not have fuzzy thing in it. But you do have a set of people who are just trying to solve a problem where they don't want to write too many YAMLs. So yeah, where do you stand, right? So it is a structured approach versus templating. No client-side templating. It's everything on the server side. So we don't have those kind of, we don't have those things like functions. It's very simple. It's kept simple because that's where we started, right? We want to keep it simple and see if there's a need to make it complex. We don't have for loops in our templating, for instance, right? So very simplistic to begin with. You can use cell expressions, but we think it's expressive enough for most scenarios. What I'd really like is about automatic dependency management. If you've ever written Terraform, you'll start to notice that you need to have a whole lot of depends on, right? I created this, depends on this, then something else. For example, you want to create a load balancer, but you need to have the certificate first, at least in the AWS world. So CRO can actually detect that you need the certificate first, so create that dependency without you actually telling CRO that I need that dependency first, satisfy the need for a certificate, and then create the load balancer and attach the certificate on the load balancer. And the way we do this is by actually building a DAC. We actually build a graph to understand the dependency chain, so we can actually go in the order for a deployment of something, roll out resources. But it also helps when we have to unwind something. So we can unwind in the same order, right? Because we have a graph that says you need to remove this first before you can remove something else. Yeah, so basically it's really safe for cascading deletions. Because we use DAC, we need to know when this terminates, and that's one of the reasons we don't have for loops, right? Yeah. Let's skip this. So let's quickly go into CRO and how this looks in CRO. So the way CRO works, oh, I need to change my screen. So it's really small, isn't it? Oh, yeah. Jupyter Notebook. I'm sorry, you have to live with this. I'm sorry? Okay. Do you know how to do that? Team and light. You asked for it. Okay. I knew that would happen because it is an image. So I'll read over what it says, right? So maybe I can just use an example here. I'll just use a simple basic example. Let's go with this. It's good enough. So what I'm doing here is I'm defining a required CRD for CRO. It's called resource graph definition, RGD in short. And what I'm doing here is I'm defining the schema and the specs that my resources will need underneath. And then I can actually pack all my resources as resources, right? Here I have a deployment, and I'm saying this ID is called deployment. It can be any name. But then I'm saying what API and what kind. What's really important is these two, right? It can be any API version kind. And what helps me is I can use the references from the schema to inject the names and things like that. I don't have to define the name and things like that. I have the schema on the top. I can basically reuse everything that comes from the schema. So these schemas are basically objects with types. When I create an instance of an RGD, that developer will provide those values for me. All right? I'm just defining, as a platform engineer, I'm just defining my stack. I'm saying what I expect from the developer if they want to roll out the stack. So the schema is what developers provide, and resources is what I'm stitching together. Here I've stitched a deployment and a service and an ingress. So anything internal Kubernetes could also be a case here. It doesn't need to be something of a kind that is cloud. So just so you know, works with both cloud and Kubernetes native stuff. Not going to jump into AWS or GCP. Just have a look to see how those use cases are supported. Yeah. Let's move on. Okay. So here I have an example. Is this a little better? Now we're back into really bad, right? It doesn't look good. We see the theme works here. I'm sorry for this. Is this better? Yeah, okay. All right. I didn't know this would happen, but we're back to the whole spa chain thing, right? So what I've done here is I've created a resource graph definition, and I call it the spa platform. Right, I'm asking them to define a location. Should I enable Airbnb for this location or disable? Should I enable B&B, bread and breakfast, or restaurants? All those are toggles that I can expose to the application developers when they create an instance of the spa platform, right? And in return, I'm expecting, once everything gets deployed, what is the status on it? So I'm just also returning to the endpoint. When somebody creates a sauna, I will return a sauna status, a B&B status, et cetera, et cetera. And down here, I've just chained all the different CRD. I created a sauna before, I've created an instance of Airbnb, et cetera. I've just chained them all together. I'm trying to say which API version, what's the kind, right? So let me just create the CRD. Oh, all right. I just deleted it if there was anything before and then just created it. So if I go to the definition of resource group definition, I see a new definition called SPA platform. So that's a single CRD that is responsible for managing all the resource group under that. Right? I've just packed everything into a single CRD now. Okay. Yeah, I will finish fast. So if I run actually to describe the CRD, I get to see it has basically created a merge of all the underlying CRD, and then it's complaining that it cannot find the Airbnb CRD and the other set of CRD because I haven't created those CRDs in advance. I only created the sauna CRD. I'll speed up now to create a sauna CRD. So what I'm trying to say is that if it's not able to find a certain CRD, it will complain. It will not come back and say that, hey, we found that, because we build those DAG, we try to build those dependency graph. When we are not able to find dependency graph, we can actually get back to you and complain. So I've created all of the things that I need. Let me just go back and create the chained up CRD. Still complains. So this time if I run, I should not see any error in terms of graph, right? The graph has been verified, the status is true. looks like this is something that is good. And the microcontroller that is actually looking into that CRD is also running. All right. So let's create a SPA platform, right? I'll share this Jupyter notebook, so if you want to try this out, you're more than welcome to try it. So I've created the entire SPA platform now. That includes location as Helsinki. I'm trying to enable an Airbnb here, a bread and breakfast, and no restaurant for you guys. This is the app developer calling the endpoint to create an instance of a SPA. Bring your own beer, right? So if I actually try to see the CRDs, you can see the CRDs are created by CRO. The way you can see that is it has Helsinki and the tag, right? That's the way I can see that these were created by my CRO instance. Yeah, so basically I've got an abstraction layer CRO that can actually create the CRDs of anything I lay as child resources, and it doesn't need to be conformant to CRO. So that's the direction we are heading with CRO. That's the direction we are going. And what that basically means for you is just a sample here, some of the samples here. I have an S3 bucket created by a controller called ACK for AWS. You can do a similar thing for Google, or you can create a cross-pane PostgreSQL using CRO and using cross-pane CRD. You can create a cert manager. So really don't care what kind of a CRD is it. As long as there's an operator to back that CRD up, we're happy. So wrap up, what's next? Early days for us. We're having monthly calls on GitHub. Join the initiative if you like it. We're looking for feedback. It's nowhere close to ready. Should not use this in anywhere close to your production environment, including the schemas of resource graph definition is not really settled. There's a lot of things, but we have a direction as to where we're heading, and if you think it's interesting, join us, give us a hint, let us know where you want to take this. I want to finish with the final note. We don't want to build yet another tool. If we do the things we want to do right, hopefully this becomes Kubernetes. I want to be able to live in a world where I can actually install Kubernetes or get Kubernetes and not need to add yet another tool to run my Kubernetes. Can Kubernetes not give me an abstraction layer if it can do so many things really well? That's the message I want to send. Thank you very much for hearing me. Have a nice day. Just a couple of